Hello, world, and welcome to another episode of the Genius Podcast. I'm your host, Joshua the Genius, along here with my beautiful co-host, Sarah Ann Mitchell.
Good morning.
And today's conversation is going to be around the topic of programming, kind of an hour of code series, if you will, just to kind of give you some basic understanding of the programming history, programming languages, opportunities as being a computer programmer. And just a little bit about my own experience and how I got to where I am now as a iOS and macOS application developer, as well as a small device technician.
So actually, I think that I just want to emphasize that a lot of people feel intimidated jumping into this field because they feel like, oh gosh, computer science and math collide in this perfect storm, right? But I think what's really important for people to know is that you are a non-traditional computer scientist, so to speak. You didn't go to college for this. And I think it's important for people to understand that you don't necessarily have to have a degree in the field in order to have a career in the field. As long as you understand the content, there's a place for you as an entrepreneur, as a programmer on a team producing a product to go to market, like an application or a website. We're going to dive deep into it. But how about you share with people, like, where did you get your entry? What was your entry point into programming?
Got you. So, I guess I would start off. So yes, she's right. My entry point into programming is more the non-traditional route, right? So most people. So I graduated or started school in 2006. Right, I started school in 2006, and so at that time, the majority of the people who worked in technology, that were especially computer programmers, were people that went to college for a computer science degree, right? When I went to college, my school was paid for by playing basketball. So where I went to school wasn't more so about academics. It was about where I was able to get my school paid for. And so the school that provided me a full basketball scholarship at that time didn't have a computer science degree program. And we think about that's less than 15 years ago, right? And we see how prevalent technology is now. And to think about a university not having a major around this industry it just doesn't make sense. But it was a real thing at that time. So I had to take my secondary love and hobby, which was psychology, right? My fascination for how the brain worked and how it operated and the underlying mechanics.
This is like
behind.
Computer science, but the human psyche, as far as I see your brain digesting this content.
Yes, and that aspect of psychology is what I loved, right? And so, throughout my college experience, it wasn't until my senior year. And this is also around the same time that the iPhone came out, right? And the release of the iPhone, for those that remember, was a very significant time in technology. It was one of the first smart devices to have all of the components all in this one central location in a device that was so user-friendly and so intuitive. So my senior year, I was studying psychology, but I was also, I started my career at Apple at that time. I started in November of 2009, and I started selling computers. I had no idea what a CPU was. I had no idea the difference between macOS and iOS. I knew that they were for the phones, but I didn't really know what they meant. And at that time, people were jailbreaking phones. I thought it was cool, but I had no idea what they were really doing underneath the hood, right? And as Sarah said, with computer programming, with where it is now, you don't have to have that traditional background, like I said, for computer science. And my experience at Apple, when I became a salesperson, it wasn't really about what I knew. It was about my thirst for knowledge and how smart was I to ingest new information, retain it,
to teach yourself.
Exactly. Right.
Personal development, professional development. Like not having somebody come tell you have to do it, but you being interested enough to look for the knowledge yourself and to teach yourself.
Correct. And that's one of the most empowering things that I can remember working at Apple is all the knowledge that was available and the supportive environment to say, hey, if you can learn this, we can place you in places to be successful. So, like I said, I started off at Apple working part time, selling computers. Within a year, I became a certified what they call ACMT, an Apple Care certified Mac technician, right? And so that led me to understand not only how operating systems work, but I was also able to go underneath the hood of these beautiful products and understand the marriage between Apple's hardware and software and see the intricacies of how that was woven together. And so I can remember before I became a technician, I remember walking in back to the Genius room, and I think I've talked about this on the podcast before in one of the first episodes. Walking into the Genius room and seeing all these monitors and seeing all these lights go off and really not knowing what was going on and feeling so intimidated around these products and around this environment. And I remember going to my lead genius at the time, Will. Shouts out to you, Will. I remember going to my lead genius at the time and saying, "Hey, Will, what do I have to do to get back here? Like, this stuff is really cool. I really want to know how it works, and I want to get paid. You know, I want this to be a future career of mine because I see opportunity here. What do I have to do?" He said, "You just got to go pick up these resources, learn them, and if you pass the test, you can become a genius." I said, "What?" Boom. And like I said, within a year's time, I stepped into that role. So that was around 2010. Between the years of 2010 and 2012, I went from being a certified technician to being a lead genius, which is a supervisor, and then having the opportunity
it's like a team lead for the technicians.
Yeah. Team lead for technicians, and then I went around the country setting up new Genius rooms as what they call like
for
a
like
kind
new
of
Apple stores.
For new Apple Store openings, they call it kind of like a career experience.
Those are cool.
So that was incredibly fun. But when we started to see, I was in South Point out in North Carolina. South Point in North Carolina. And me and a friend of mine were having a conversation about the music industry. We were having a conversation about the music industry. He's also a genius. He was working in New Orleans at the time. And I was a genius out in North Carolina. And we were having a conversation about how applications could be beneficial in the music industry. How the power of software, of servers, of streaming could be beneficial to independent artists. And so that conversation around the creative artist now being or now interfacing more with technology and the emergence of new platforms, right? Came the opportunity for me to learn how to build mobile applications, right? So I was a genius working out in North Carolina and having conversations with a friend of mine and thinking about how we could build this new mobile application, but we had no prior programming experience, right? And so the conversation at that time, this was in 2012, I believe. So the conversation was, okay, so what are we going to do to make this happen? Are we going to pay somebody else to do it, or are we going to build it ourselves? And if we build it ourselves, we keep more profit, but if you have to pay somebody, that's open up to people with more with more revenue shares, and just bringing more people into the idea. And so that was the first time I picked up a programming book. It was around 2012, 2013. It was my first time that I picked up a computer programming book and said, hey, I want...
What was the language that you selected to learn?
The language at that time, so there's a plethora of different computer programming languages that have come before and that are popular now, which we'll get into here shortly. But the one that I was most interested in, of course, was ObjectiveC. And ObjectiveC is the programming language that is a derivative of the language C, or the foundation of C. And so we'll get more into
C++. I see that floating around.
C++ is another derivative of C. C# is another derivative of C.
Okay.
But ObjectiveC was kind of about bringing a more object-oriented perspective around to the language, yes. And so now that ObjectiveC has transitioned into Swift, and we'll talk about that here soon. But ObjectiveC at this time was the primary application or excuse me, the primary language that you needed to learn if you wanted to develop any mobile application for the iPhone, right? If you wanted to develop your own mobile application, you had to learn Objective-C. Now, again, me not having any traditional experience, my traditional experience at that time was in the repair and maintenance and upkeep of software and hardware, not the actual creation of it, right? So this is a couple layers down. And so just as I saw the opportunities in how to be a technician, there was plethora of opportunities in being a software developer. But the I guess the anxiety of learning something, it's kind of like learning if you're trying to teach yourself Spanish.
It's right? Another language.
Yeah, like I'm pretty sure there's people out there, or you guys have friends or family members that have picked up Rosetta Stone and tried to teach themselves Spanish or teach themselves French. It is it's not a difficult process, but if you have the ability to learn, right? If you may not have the background understanding of computer science, but the way that computer programming right now is set up, if you have the will to learn something new and you have the passion to want to learn something new, then computer programming is wide open for you. So at that time, learning Objective-C, I learned out of a textbook. Now remember, this is back in the 2012, 2014, around that time, right? I was learning right out of a textbook. There wasn't all these different platforms available. There weren't that many YouTube. Yeah, there weren't that many YouTube teachers out there. Either you learned traditionally from a university, you went to a specialized school, kind of like ITT Tech or something like that, right? Or you taught yourself. And so at that time, I was working for Apple. I didn't have the opportunity to go back to school. So I picked up a book and I spent my 8 hours working for Apple. Then I spent another maybe 6 hours at a coffee shop every single day, opening up a textbook, flipping pages, trying to crunch these new concepts and crunch these new understandings, right? So in about a year and a half is where it kind of all started to make sense, right? And when it started to make sense, I was offered the opportunity to go to Cupertino and work on the iOS team. And we were I was on the quality assurance team going through quality checks of iOS. At that time, it was iOS 13 and 14. No, excuse me. No, that's current. That was iOS 7, I think. iOS 7 and iOS 8, if I believe. Yeah, iOS 7 and iOS 8. So yeah, going through quality checks through those operating systems and working with a development team, right? Working alongside the developers that build the software that all of these applications run
on, yeah.
Right. And so as you know, I had amazing opportunities. It was an amazing experience, but it got to a point where I said, hey, there's some things that I've been working on that I want to do for myself. And
you know that intellectual property clause when you first start working at Apple, like, you're not about to build no apps and say you own it. Like, Apple gives you the resources, but they will also lay claims to your intellectual property.
Yep. And so that I didn't remember until it was kind of
hit the wall.
It's too late. Yeah. I kind of hit the wall where I had all of these resources. I was a certified technician. I was basically a certified developer in iOS, right, in Objective-C and Swift. But I couldn't develop applications for myself. And so I came to a decision. Was I going to stay with Apple and continue my journey with them as a software developer? Or was I going to try my hands in the open market and see if I could get any of these applications, get them sold and get them rolling, right? So from the years of about 2014, 2015, till now, I've been working with a myriad of different clients in myriad of different sectors. I've worked with the Indy 500. We developed an application for NOLA Motorsports. It was the Nola Motorsports company. It was their first time having one of the Indy 500 races in New Orleans.
Hosted at their track
It was
or their
awesome.
facility.
It was an awesome experience. We did the application for them. We worked with a couple government sectors and building application backends for them. We've worked with some entertainers in the music industry, building some game concepts and kind of
Like
marketing
rolling out an album
applications.
through a game. I think that's dope.
Yeah, we rolled out albums. We rolled out beat packs through one of his games. It's called Diamond Man. It's still in the App Store. You can download it.
It's lit.
And so, and then now we're down here in the Virgin Islands, but with the way that technology works now, I'm still able to support my clients in the States and all over the world. My team, my development company is called GeniusLogic, and I work with developers from all over the world. I work with developers from Brazil, from the Ukraine, from Australia, from China, and only at the top, right? So with the ability, with the network that I've been able to build with Apple, with some of my colleagues, we get on one project, and I build the team around that specific project to get that done, right? And that's only out the maybe top 5 to 10% of developers from around the world. And so I'm also a member of Phi Beta Sigma Fraternity Incorporated, and me and a frat brother of mine, we created My Greek Emoji. And My Greek Emoji is a sticker application that you can also still download in the App Store.
Oh, you forgot about the VI Massive sticker pack.
And also the VI Massive sticker pack. Man, yeah. So we work on a lot of applications. But back to My Greek Emoji. My Greek Emoji is for the Divine Nine. So that's the 9 fraternities and sororities, black fraternities and sororities of colleges and universities. And then VI Massive is another sticker pack for the just for
Virgin
general
Islands culture and
for,
pride. Okay, so now that you've told us a little bit about your entry point into computer science and programming, let's give the people a little bit of a history on computer programming in general.
So there's a start that the Western civilization was at. Her name is Ada Lovelace, and she basically created an algorithm for a particular device, and that's what they look at as kind of the starting point of computer science and computer programming in the Western civilization. Now we can step back 3,000 years ago, and we look at ancient Egypt, and we look at the binary system, right? Scientists have observed the binary system in ancient Egypt through hieroglyphs and other studies that they've done of the environment, and seen that math, right, shown 3,000 years ago. And the reason why the binary system is so important is that's basically the foundation of all computers.
Run on binary.
Right? Right now we talk about quantum computing, and as we go up, we get out of the binary system, but those are new frontiers. But as of what we currently in what we traditionally understand, we're based in the binary system, and the binary system is zeros and ones, right?
Yes or no,
true or false,
on or off.
Yep, right. And so working in that frame, we can see how programming languages have developed over time, how we've been able to manipulate the binary system, right? Where we've gone from a circuit board, a CPU having an architecture of maybe, let's say, 100,000 transistors that we can manipulate on and off. Now we get to CPUs having over 1 billion transistors that we can manipulate on and off, right? And the sequence and the pattern to which these transistors are turned on and off gives us certain feedback.
Certain outputs.
And from that certain feedback or output, we can then manipulate in another way to show video, or to show sound, or to hear sound, or for the key K to show up on the screen, right? Or for when I hit this on the screen, it does a shutdown. So all of these are the manipulation of the binary system through computer programming, okay? There's a difference of computer programming languages. There's low-level programming languages, and there's high-level programming languages. So let me read you the definition of the two. I think I have it up here. Yeah. So a high-level language is one that is user-oriented and that it has been designed to make it straightforward for a programmer to convert an algorithm into program code. When you look at, let's say, let's put this into a metaphor. If I am a mechanic, okay? If I'm a mechanic and I'm dealing in high-level computer programming, I can look at the book, right? I can look at the book and be able to take off the tire. Be able to know, okay, I need to take off these 5 lug nuts and take off the tire. The high-level programming is me looking at the book and I can read it and understand it's very intuitive for me to do and manipulate. Low-level programming or low-level language programming is machine-oriented. Low-level programs are expressed in terms of the machine operations that must be performed to carry out the task. So low-level programming is, with that same metaphor, if I am an engineer, okay, and I am actually creating the, what is that called? The holster that the tire goes onto, right? I'm not taking off the tire and just manipulating the outside of it. I know the intricacies of the inside and I'm able to manipulate it at the interior level. Low-level programmers know how to, they program particular machines, right? Let's say if I were a manufacturer or a programmer at a car manufacturer plant. If I am a low-level programmer, I'm going to program how let's say we're working with electric cars, I'm programming how the electricity is flowing out through the entire car. Low-level programming. I'm turning on the switches on and off to make sure that the electricity is regulating through the machine, right? Through the machine. Machine-based code is a lot of ones and zeros, on and off. It's a lot of binary language understanding, and you're manipulating at the lowest area that you can manipulate, right? High-level programming languages would be in that same metaphor. Let's say I wanted to program the dashboard. I want to program the dashboard of my electric car, and I want to put the icons on the screen that bring up the phone call panel when I press the button, right? I'm not manipulating the engine. I'm not manipulating the basis of the car. I'm manipulating the higher parts of the car, the feature sets of the car, okay? As an iOS developer with Swift, as a high-level programming language, I'm able to adjust how the screen looks. I'm able to adjust how I can use the camera. I'm able to adjust how the gyroscope is if I move the screen, how the screen will tilt, maybe if I'm playing a game or trying to balance out a picture. If I'm doing low level, which that would be the ObjectiveC or going back into C, which we'll get here in just a minute. If I'm going into more lower level programming languages, I get more access to the device. Higher level programming languages are created to be very, very powerful, but they're created with security to make sure that if you open up something in a different area of the phone, you're not going to damage it.
Shut down the whole
or
thing.
Or have an operation running that's going to overheat the phone or make it harmful to a user. Low-level programming languages are for more so the creator, manufacturer, or original innovator or developer of the product, or someone who has to come and do maintenance on that product, right? A lot of these lower-level machine-based codes are, used for ATM machines. They're used for airplanes. A lot of airplane companies, telephone companies, all use a lot of older low-level programming languages. So to make it make sense a little more, let's go through some of them. So we start out with the assembly language. The assembly language was created in 1949. And the assembly language is a low-level programming language that simplified the language of machine code. Machines understand zeros and ones. They understand on and off. So before, you had to understand the binary system. Now, me, myself, I can't tell you what the binary output of my name is. Because each letter in my name is 8 characters. And so my name is going to be a string of those letters in binary that the computer will understand, right? The computer will understand that zeros and ones and be able to interpret it as Joshua. But if me as a person, if I go read zeros and ones, and I'm reading a long page, eventually it's all going to look like mush because I don't understand it. That's lower level programming languages. That's machine-based code, knowing how to manipulate on the zeros and one level. So the assembly code in 1949, or the assembly language, was created to make that a little more intuitive, to make it a little easier for you to manipulate the zeros and ones for a certain output of a machine. And you have to remember, at this time, you were working with large mainframes. You weren't working with, small
user personal computers.
When you were working with mainframes, you're working with switches, right? Turning things on and off. Big wire boards that you have to plug, on and off, or move sockets in and turn levers on and off to get certain outputs to happen. Okay, assembly language helped with that, making things a little more digital and made it a little more intuitive and user-friendly to manipulate machine code. Okay, so that was in 1949. With 1957 came Fortran. Now, Fortran is the oldest programming language in use today. It's created for high-level scientific, mathematical, and statistical computations. Okay, Fortran is used in a lot of banking systems. It's used in a lot of high executive companies where they have to process a lot of statistical data. So the programmers that are working in Fortran have to develop applications or develop software that works with certain machinery that's able to process this information. And what I mean by that, if they have to develop applications, those applications have to be able to store that information correctly, right? So they have to have a software that they build that stores that information correctly. If they have to build software to work with a machine, well, let's say some record keeping at that time, this was back in 1957, they're working with maybe a long piece of paper with punch holes that they have to feed through a reader. And that reader has to be able to read that paper in those punch holes correctly.
Scantron.
Yes. So Fortran can be a programming language that you choose to build your software in. Okay? And like I said earlier, there's a number of programming languages. It's, as a programmer, if you want to be a programmer, it's about what kind of programs you want to build and what kind of machinery you want to work with. Or from a user standpoint or a company standpoint, how efficient is this programming language, and what is the longevity, right? What's its shelf life? How long is this programming language going to be around? How long is it going to be supported? And so we look at Fortran being the oldest programming language in use today from 1957. Okay, so that means that there's still companies.
Pretty sure the companies that tally the ballots for elections use machines that are powered by that technology.
And so we talk about why things take so long. We talk about why when one system goes down in 2021, it takes out an entire
we gotta find people
platform.
Who could code in this language from the 50s to fix it.
There are not, and we'll get into resources in the path, a couple paths that you can take to get to computer science, get to computer programming through computer science. But there aren't universities out there that are teaching Fortran right now. Now you may find specialty schools, or you may find they may have a group or something, or people may have a little club. But when you go there, you're not learning Fortran. But there's still Fortune 500 companies out there that are using it. And I mentioned Fortune 500 companies because those are the companies that we look at to kind of give us the scale and efficiency of how our entire economy is doing. So if we have Fortune 500 companies that are still using software for over 50 years?
Yeah.
Over 50 years old. Think about...
more like almost 70 years old at this point.
Right? So think about if, as much as we've talked about software updates, think about if you had a software on your phone that was being updated, but it was really 70 years old. These companies need to update, but for them to update, that's a massive overhaul.
Undertaking, yeah.
That line item is going to be astronomical, but that's outside the scope of this conversation. Let's get back on topic. Fortran. So Fortran 1957. Then we have Cobalt. Cobalt is 1959. Cobalt stands for Common Business Oriented Language. Okay, and so this is one that's also used with ATMs. It's used with telephones and cell phone companies to create cell phone calls, hospital signals, and traffic signal systems. Okay, so when you're riding around and you want to know what software is powering the traffic lights, right? I had a friend of mine that had a friend, and every time we called him, all you heard was clacking on the keyboard. That's all you heard. Every time we called him. The reason being, he was one of the head programmers for all of the trains and trolleys in New Orleans Parish, right? So he had a high level view of how all of the trains were moving throughout the entire city. And on the fly, he could go in and redirect through the software. Oh, no, I need this to be rerouted. Boom. Right? He got paid crazy money. But in front of the computer as a programmer. And we'll talk about the differences of like
all that. Replacing the jobs of the actual trolley drivers? Is
well,
that a thing? Or that's a different trolley?
No, that's a different trolley. But the point I was talking about is more so to computer programming is fun. However, the trade-off is that you have to be in front of a computer
all the time.
So that's the trade-off. We'll talk about that here soon. But make sure we put that as a point to talk about. But we'll talk about that here soon. So Cobalt. So if you use ATMs, like I say, the standard telephones, there's not too many landline phones or pay phones anymore. I think I've maybe seen one here. I don't know the last time I've seen one in the States. They've all been pulled from my understanding. So Cobalt is a software that was built to make those things run. It was to help companies have one kind of general programming language that they could institute into their banking services and communication services, so that would be easy for customers to use and it would be easy to maintain through a business architecture, right? Then we move into 1964. 1964 brings us BASIC. Okay, BASIC is probably the programming language that most computer programmers start with. Now we're talking about those computer programmers pre 2000 or pre 2010, right? The first one that they probably came in with was BASIC and or C, right? BASIC is the beginner's all-purpose symbolic instruction code. I'll say that one more time. BASIC is the beginner's all-purpose symbolic instruction code. It's written for students who did not have a strong understanding of mathematics or computers, and it became the first marketable programming language of Microsoft, right? So Microsoft had a big marketing campaign behind BASIC. It's what a lot of their underlying softwares were built on, right? It's what the universities started teaching as kind of, hey, if you want to get into computer programming, BASIC is the first computer programming language that you need to know. You don't need to go all the way back to the assembly language, Fortran. You can, and there are certain programs that start you at the assembly language, start you at machine code and move forward. But now in 2021, a lot of the marketable skills, right, or the more popular skills are in high-level programming languages. And we'll get more into that here in just a minute. So that brings us, so we went from 1964 to 1972. 1972 brings us the all-famous C programming language, right? The C programming language was built under the Bell Telephone Laboratories for use with the Unix operating system. And many of the current leading languages are derivatives of C. And as I was telling Sarah, that those derivatives are C#, Java, JavaScript, Perl, PHP, Python, and C++. We'll get to those in a minute. But back to C. C was built for Bell Telephone Laboratories. And Bell Telephone Laboratories was Alexander Graham Bell, right? Alexander Graham Bell created a company that was basically the first telephone company. Like basically first telephone company. And through that company and through some other scientists and developers, they created the programming language of C that became basically the standard for general purpose computer programming. If you wanted to start building platforms for your businesses, you wanted to start building interfaces and dashboards for your businesses, if you wanted to start building websites, and we start getting into building the websites, not just the building or not just the development of programming languages for machines to make machines operate. Now we're getting into more user interfaces, right? And so that gets us more into higher level programming, being able to manipulate the user interface. And so that's where C starts. And so from C, we also get SQL or MySQL. SQL is the database, right? It gives you the ability to be able to create database structures and to be able to store and manipulate the information that is in those databases. So the majority of, I would say, all of the applications that you use now all have to have some type of database structure. And the majority of the time, that database structure is through some type of MySQL programming of a database to allow getting and setting of that information back and forth. So when you create user profiles, or you store pictures in your applications, or you store videos, voice memos, you store any type of content in these third-party applications, they have to have a database for that information to live. So there has to be programmers that create those databases, right? Which is not the same person that could create the actual application, right? So like for myself, I don't program server-side databases and applications, which means I am not fluent in MySQL or the SQL programming language or the SQL architecture. I am familiar with it and I can work with it, but if you want me to build a database for you and an architecture for you from the ground up to make it work and interface with a front-end application, that's not my expertise, okay? Now we do have developers that we refer to as full stack, okay? Full stack developers are able to build the front end, so they're able to build the interface that you as a user are able to manipulate, right? The buttons and different icons and everything. Mm-hmm. And then they're also able to build the back end. They're able to build the database in which all of your information is stored and all your preferences. They're able to make sure that that's stored and works well and is able to be read well over the course of you using the application. They are also able to sit in on meetings and be able to talk about the higher vision of the application and where it should go and how it should be created, kind of the blueprint architect of the application, right? So full stack, having the front end knowledge, being able to create the front end, being able to create the back end, and also being able to have the conversation between the two, right? Knowing both sides enough to know what technologies to use as a cert, what technologies to use on your back end, what technologies you need to use on your front end, and how to put those together, right? So you can specialize in a computer programming language, or you can go full scale, right? Full scale, full stack, and learn from the top to bottom, right? And each side has its advantages and disadvantages. We'll talk about that here soon. But getting back to the history, we go from SQL to ObjectiveC in 1983. 1983 ObjectiveC is the main programming language used to write software for macOS and iOS. It's Apple's main operating system at this time. Right? So this is where I started. 1983 was 5 years before I was born. when this programming language was created. I started learning this programming language in 2013, 2012, 2013, right? And so Objective-C is a derivative of C, but it's more object-oriented, right? With C, you kind of had a bird's eye view of everything. With Objective-C, it kind of segmented areas and kind of encapsulated certain features and functions and areas into more manageable parts, right? So it was easier for me to come into understanding Objective-C being a non-traditional programmer, because Objective-C, in the way that it was built, was user-friendly. It was intuitive, which means that learning it made sense. It wasn't so abstract. It made sense. And with Objective-C, object-oriented allows you to kind of safeguard yourself to where you can't mess up things too much, right? It does. We talk about memory sharing and memory usage in computer programming. The way that your application uses and manages memory is going to directly coincide with how efficient your application is, right? With Objective-C programming, it was easy for you to have a memory leak, right? A memory leak is you maybe not, you opening the use of memory and not closing it, or overusing memory, using up too much memory, asking for more, and there not being enough there, and then having things crash. With Objective-C programming, as a programmer, I was beginning to understand the rules of memory usage, but Objective-C is created in a way to where, as you're programming, you aren't fully crashing or fully compromising your application because you don't have access to certain parts. Now, to get access to certain parts, you would have to go back into C or back into a different programming language in what we call IDEs. And I know I'm using a lot of acronyms here. We're going to put all this stuff in the resources, but this is just a basic understanding. We'll get into more details in subsequent podcasts and like little mini series, but just stay with me. So we get into IDEs. And IDEs are what we call integrative development environments, right? Integrative development environments. And I've talked about one of them for iOS development, which is called Xcode. Okay, that's Apple's version of an IDE where you can open it and it's your application as a programmer to have all the tools and resources you need to develop an application. All right. So in your IDE or in Xcode, Xcode supports many different programming languages. So if you want to build in Objective-C, you can do so. But if you need deeper manipulation of your program or of the system, you can use another programming language in unison with the newer programming language to get access. So if I wanted to manipulate memory usage, or if I wanted to change the camera in a really specific way that I didn't have access with Objective-C, I could do so in C. But I can only do that if I knew C, right? I can only do that if I knew C. That goes back to if I want to know the full stack of all these programming languages, or do I only want to know a specific few? Do I want to specialize, right? So we go from Objective-C into Python. How are we doing on time, Sam?
We are at 50 minutes.
50 minutes, okay. I got about another 25 minutes. About another 25 minutes with you guys. So we go into Python. Python is 1991, right? Python is 1991, and it's a general purpose, high-level programming language created to support a variety of programming styles and be fun to use. So Python is kind of, if you want to start getting your feet wet with computer programming and website building and a little bit of mobile application development and maybe a little bit of gaming, this would be a good programming language for you to start with. It's a great high-level language. Python is super, super popular. It's used to build tons of websites, tons of different platforms. It's very easy to use. It's one of the newer languages, and I think one of the top 5 programming languages. Oh, excuse me, one of the top 5 programming languages in use today. And so that came out in 1991. Ruby is in 1993. So it's interpreted as a high-level programming language made for web applications. So you'll see that there's multiple applications for the same thing, but each have their own unique way of doing it. So you'll just need to do some more research into where you want to go, what you want to do, and how you want to do it, and then that can kind of get you on the right track for which programming language you should start with. Yes. So then we go into Java, 1995. Java is also a general-purpose high-level language. It's cross-platform, right? It's used for web apps. So web apps are kind of the mobile application without the ability to have access to the hardware that's on devices, right? So there's been this big fight between, should I do native application development or should I do a web app, right? And so the difference between the two is kind of what access of the phone are you trying to get to, right? If you're just trying to build like a cool social media application that just has a little bit of content, or you want to build like your own kind of like artist page or influencer page, or if you want to do maybe like a little e-commerce, you can do that through a web application, right? And a web application is basically a mobile app that's just available through the internet, right? It's a website. It's a mobile app developed through the internet. The difference between that and a native application is a native application is built with the programming language specifically for that platform, right? So if I build a web app, I can build a web app in 3 or 4 different applications. But if I want to build a mobile app for the iPhone, I have to develop it in ObjectiveC and now Swift, right? We'll get to Swift here in just a minute. And the ability that you get with a native app is that you have the ability to access the intricate hardware that is on the phone. So if you want to use the cameras in a certain way, if you want to use the gyroscope in a certain way, if you want to use the microphone in a certain way, web apps gain you access to some of these areas, but the native applications give you full access and give you full ability to manipulate the actual hardware of the device. So if you're building an application that is dependent upon Apple's hardware or a device's hardware, it's best to develop in that native language, as opposed to if you're just building a website that you want to look like an application, then a web application is fine. Web applications are much they're not least expensive. They're
There's a lower barrier to entry as far as
no. They are they don't cost as much as native applications. Native applications, you have to get actual programmers that know the language to build, as opposed to web applications. You can either build that. There's a lot of platforms that you can just kind of like a cookie cutter kind of template type of thing that you don't really have to have any programming experience to build those type of things. So we're more so talking about programming with native languages. That's what we're going to focus on. But there are programming languages out like Java, which is very, very popular. I think Java, is either top 1 or 2 programming language now. That a lot of websites are web apps, right? It's not just showing you content. It's giving you the ability to actually manipulate things and add things and host content and do all these other cool features that didn't come with a standard website, right? And that's where Java comes in to give you more options around the features available to you through a website. But that platform is still limited in comparison to native application development, right? So moving on, PHP comes in 1995. PHP uses include building and maintaining dynamic web apps, as well as server-side development. So PHP is used in unison with MySQL to build server-side applications. So you can be a PHP focused computer programmer and focus on just building server-side database architecture. And when we say database architecture and server-side, we're talking about things like Amazon Web Services. And you can look this up. A is what we call AWS. It's Amazon Web Services. And as a developer, you have two options. You can either host your own server, which means have your own computer, like locally or somewhere in a business local to you that you can put your hands on, and have all of your data run through there. Or you can buy space through Amazon, right, and buy one of their computers virtually and have all your data run through one of theirs. Now there's pros and cons to both of the two, but if you do a local, right, you got to think about scalability. You got to think about how many servers you'll need, right? How much upfront cost do you need for how much user traffic you're getting in through? Whereas Amazon Web Services, you just pay for a month, you pay a monthly fee, and it scales for you, right? It scales for you. So you have to have a.
That's how Bezos paid for his rocket ship.
There's a lot of people around here who are talking about Amazon and buying products through Amazon. And yeah, Jeff made a lot of money through that. It's Amazon Web Services that are getting into space.
Paying that money, yeah.
Because I would bet to say over 75% of the industry is using Amazon. If you are a independent developer, 75% of us are using Amazon Web Services, or an affiliate company that then piggybacks off of Amazon Web Services. And that's because they have built these huge mining farms, these huge data farms and huge server farms to hold. They saw this coming. They just built the infrastructure, and now they get companies to pay them to host their content, and they make sure that it's dynamic so that wherever you are, you have access to it. Now, if you're an independent developer and you have your own server, you have to manage all of that, which is a much larger upfront cost, more control, but larger upfront cost, as opposed to if you buy Amazon Web Services, lower cost, not as much control, but it's scalable. Right? So that's PHP. So if you want to get into server-side development, if you're more into database management as opposed to like putting colors and text and buttons on a screen, PHP would be good for you, right? If you're more on the structure side, more into foundational math, right? The server side would be good for you. If you're more into the user experience and user interface and creating, we'll get into Swift, which I am specialized in. We'll get there in just a minute. We're at 2000.
C Sharp.
2000 brings us into C Sharp. That combines BASIC and C++. So C++ is another kind of machine-based not operating system, but computer programming language, and BASIC. So C Sharp is basically the combination of BASIC as a foundational computer programming language and mixing it with a machine-based computer programming language for better understanding. So if it was difficult for you to learn assembly, which is strictly machine code, and you understand BASIC, which is higher level programming, right? Then you can learn C Sharp to help you with the lower level programming language, right? C Sharp is also used in a lot of industries currently to run a lot of machine factory equipment and a lot of retail equipment or office equipment, such as like big printers, faxes, things that big corporations need to use and operate their daily operations inside of the business, as opposed to like farmers and things that need to be able to program tractors. C Sharp is used more in that environment. 2009 brings us to Go, and Go is a programming language developed by Google. to address issues that occur due to large software systems. So Go, I think Twitter uses Go. Google, of course, uses Go for some of their platforms, and I want to say Instagram also uses Go. But it's a scalable programming language that large platforms use. And the reason why is so when you get into large platforms, you get into a lot of moving pieces. That in order for your website or application to run properly, all these moving pieces have to be in unison. They have to move in at the same time. When I say move, every time I need to move. In large platforms like this, sometimes those things don't happen. With other programming languages, it might be more difficult to pinpoint those areas or fix those areas once they come about. With Go, it's a programming language that from its initial rollout thought about those pain points and said, okay, hey, when dealing with large architectures or large platforms, we've created a language that can help you with the management of these large platforms. So if that's something that you're either working on independently, or you get into a corporate job and you're working with something like on Google's search engine, think about how large Google's search engine is, right? And all the moving parts and components that may have to be pulled from that SQL database. Go has been implemented as a programming language to help with that, right? So that is into 2009. And to end the history brings us to 2014, which brings us to Swift. Yep, brings us to Swift. And Swift is the concept behind Swift is kind of in the name, right? They wanted to make programming much faster, right? They wanted to bring the ObjectiveC programming language and kind of put nitrous in it. ObjectiveC made programming a lot easier from C, and Swift just multiplied that times 5, right? They've cut out a lot of the fat of older programming languages, and what I mean by fat is a lot of the kind of redundant steps that we needed to take just to get to one endpoint or to one feature or to one solution. They've kind of cut some of that out. Some people feel that Swift kind of puts handcuffs on you because it decreases how you're able to manipulate the underlying technologies. But like I said, there are other technologies that Xcode supports. So if you have other things that you want to do with your application, you just have to learn those other languages. But if you're building standard mobile applications or standard Mac applications, the WWDC app, you can look this up in the App Store. The WWDC app is built all in Swift. All in Swift. It deals with databases. It deals with beautiful icons. It deals with a intuitive user interface. It deals with a very, very snappy and responsive user interface. Like Swift is not just for standard applications. Swift can be used for high-level architectures and enterprise applications. And so Swift is, since 2014, is in our industry, is becoming pretty much the standard. Right, it's becoming pretty much the standard. And Swift, that's the first time Apple has done this, they open sourced Swift. And open source meaning that other developers can work with the feature sets and other SDKs, software development kits of Swift, and be able to add new features or bring new ideas to the operating system. They can say, hey, we see how this is working. This is what we think it should be because this works better. Hey, Apple, what do you think? Oh, yeah. Okay, we'll take that. We'll put it in to the entire operating system. And that helps build the operating system up over time, and it helps keep it current, and it helps keep it intuitive with the users, because since it's open source, users can give their feedback, right? So Swift is the programming language that I specialize in. It's what I build most of my applications in now, and is what I teach here in the Virgin Islands. Since being here in the Virgin Islands, I still do computer programming, but I teach computer programming as well. And I more so teach in the iOS and Mac OS, the iOS and Mac OS environments.
So I kind of this is kind of just like a quick recap of the history of what you're talking about. I want people to understand, like, if I want to pursue website development, these are the languages that I should be considering learning. Or if I want to jump into virtual reality, 2D, 3D gaming, programming, these are the languages I need to look at. So I can kind of run through the list if you want, if you have feedback or if you have comments to add to each item.
Sure.
So the first one is for web development. So those languages are going to be JavaScript, HTML, CSS, and then I have JavaScript again. HTML is basically like building the frame for the house as far as web development is concerned, and CSS is like interior design component of that relationship, so making the house look pretty. Let's see, the next one, server-side apps with Java. It has Node.js.
Yeah, Node.js is technology to kind of bridge the two to work with the server-side database with your front-end website.
Okay. Next, iOS and macOS application development, which you just talked about with Swift.
Mm-hmm.
And I'm I've only, my experience with programming has mostly been with HTML and CSS for websites, but using Swift Playgrounds to learn Swift has made it more accessible, and it's kind of given me the feeling like it's not as hard as I guess I imagine it to be. Next, we have another one for website development, which is Ruby on Rails. Let's see. We have C#, which is general purpose cross-platform coding with, how do I say that?
That's Xamarin.
Xamarin. That's virtual reality, 2D and 3D gaming.
So Xamarin is a platform that came out, I would say 2020, maybe about 5 years ago, 6 years ago. And it was kind of it was to say, hey, we can make mobile applications without using the native language, and we can make them just as good. Yeah. And so there were more people that knew C# or C that didn't want to learn Objective-C or Swift, right? Mm-hmm. So they were like, hey, let's make a platform that can use an older programming language like C#, which the C# developers believe is still valid and still has scalability. Let's build in that because that's what we know, right? And still be able to get the benefit of distributing to iOS devices and macOS devices and macOS computers. So that's Xamarin. I've never used Xamarin. Also, another benefit of Xamarin is that since it was built in C#, the Xamarin platform does double deployment. It does for iOS and Android. That was the benefit of Xamarin.
Okay. Mm-hmm. Okay, so the next one on our list is Go, which again you mentioned was developed by Google, functions similar to C, and is for web servers, data pipelines, and machine learning packages. Mm-hmm. All right, next we have Rust. Notes I have here are it's an upcoming language, and there's an emphasis on speed and security, but this one would be a low-level language, as opposed to most of these are high-level languages.
And again, low-level is dealing with basically programming zeros and ones. High-level is dealing with more text, right? Typing text on a screen to execute zeros and ones, right? That's the difference, right? High-level languages are built so that they are easily interpreted by humans and people. Low-level languages are built to be interpreted directly by machines. Okay. And so, thank you for that roundup, and that'll get us right in here to salaries.
Yeah. So now looking at job opportunities with these specific programs, but from a quantifiable perspective, like how much money can I actually make writing these codes?
So before I get into salaries, there are, I think the last statistic as of maybe about a year ago was that there's over 1.5 million jobs that will not be filled in the next 5 years in the technology industry. and a lot of them have to deal with computer programming. The reason why these jobs will not be filled is because our workforce, the American workforce, doesn't have the skill set, which means
We're
that
busy losing our jobs to artificial intelligence. What do you mean?
as our economy grows in technology, just like when our economy grew when what was it, Henry Ford, right? Built the first standard car. We started getting manufacturing plants of cars. What do we need in those factories?
People who work the machines.
Who knew how to work the machines, right? That makes sense. That means that our economy is growing, and more things are coming about. We need people to fill these seats, which means that the universities and the schools to start teaching the kids.
The curriculums have to reflect
exactly
the work environment. This is
it
the
should
problem.
be hand in hand, right?
We have kids going to college and get out of college, can't find a job in their field, when we should be kind of reverse engineering our collegiate programs to reflect the job industry that our scholars are going to be entering once they graduate.
I started this conversation.
Seems simple, no?
To say I did not have a computer science degree program at my university in 2006. I was there from 2006 to 2010. I believe the computer science department started maybe 5 years ago. Maybe. I'm sorry if I'm wrong, but I think it's about 5 years ago. Right? Just after that, that's not that long ago. And we're dealing with almost coming up to quantum computing now.
Yep. University of Chicago knows what's up.
What? Right? So the landscape of our economy, right? The landscape of our economy is being grown into a place where if you don't understand technology, if you don't understand computers, you're going to be left behind. Because I'm going to tell you right now, I'm tired of hearing, I don't know. Or I'm tired of hearing, I'm not a tech person.
Oh my God, yeah.
I
want to hear some more of, I don't know, let's find out.
Yes.
That's what I want to hear.
Yes. Because this is just like you going to the mechanic. And you tell the mechanic, I'm not a car person. What? If you tell the mechanic you're not a car person, they're going to take advantage of you. You go and buy a car somewhere, you tell me you're not a car person, they're going to take advantage of you. Why? Because you're unknowledgeable. How is that going to work in your actual work life? You go to your employer. You tell them, I don't really know how to use email. I don't know how this works. I don't know how to. I don't know the basic understandings of computer programming. Right now, there might not be a lot of employers asking you, do you know what a function is? Do you know the difference between a constant and a variable? Do you know how to loop code? Do you know how to do these things? The reason why is just as Sarah was saying, we're worried about losing our jobs to automation.
Who's writing the code for these computers that are filling the jobs? It's a shift in the job industry.
Who needs to be there to be able to say, oh, this is failing, let me jump in real quick and fix it and troubleshoot, right? I'm not a mechanic. When I came here on the island, I wasn't a mechanic. But I had to figure out, oh, wait, I'm in a different place. I may not be able to get to Pep Boys. So I gotta learn how to change oil.
Figure it out.
I gotta learn how to change oil. I gotta learn that. Right? In 2021, right? Think of how many passwords you gotta remember. Think of how many technologies you're using, how many applications you're using right now. How dependent upon on technology you are in 2021. Companies are taking their, especially in post-COVID or in the pandemic and post the pandemic, are taking their businesses virtual and changing their business practices into a digital experience. how do you expect to survive? Now, I'm not saying you have to learn an entire programming language, but just as I was told in Texas, it might benefit you to learn Spanish. That's what he told me. Teachers, employers.
Can't ignore the fact that this is where the world is going.
It was a say because, hey, employers will pay you more if you are bilingual. And there are a large quantity of people in Texas that their first language is not English. So if I walk into a job interview and I say, hey, me and him are the same, but I'm bilingual, I can speak directly to your Spanish-speaking customers, that's going to immediately put me above somebody else that we might be exactly the same. In 5 years, if I go into Macy's and I'm going in for an operating position, if they're aware that I am a computer programmer or I have this this foundational knowledge, I may not get that first opportunity, but there are opportunities you can apply for based upon the skills that you have.
I think people need to start looking for jobs more from the perspective of assessing your skill set as opposed to only assessing either your education or it's like a combination, because all the experiences that you have in a working environment and also in an entrepreneurial environment or otherwise contributes to the niche that you work yourself into. So being able to combine a versatile set of skills makes you more appealing as a job candidate. You know what I mean? It makes you more well-rounded, being able to think across various content areas as opposed to just being kind of in one lane.
1,000%. Just like you're learning a language to speak to new people, you gotta learn how to speak to computers. You gotta learn how to speak to computers. I can't stress that enough. Because for those that are just thinking in the now, we're thinking 5, 10, 15 years from now. What is the world going to look like in 2030, 2035, 2040? Who is going to have the advantage and who isn't? And that advantage starts now. Because we look at computer programmers that are fluent in the Go language, $140,000.
ObjectiveC,
$135,000. Let's go down a little bit more. Rust, $130,000.
Swift,
$125,000.
See what else? C++.
C++, $120,000.
Java and Python.
Now this is annual. This is annual. And now I may hear somebody saying, that's not that much. It's not that much money.
Nah.
Wait, hold on.
Nah.
Hold on.
That's not that much money. The people we're talking to are underprivileged minorities who historically are not represented in these positions. And we want to encourage people who would otherwise think that they cannot access these types of jobs. This is at your fingertips. All you got to do is deepen the knowledge you have in this area so that you can be competent.
$120,000 is more than what 20% of the American populace see. Wait, that's that right? No.
Let's put this in perspective for people living in the Virgin Islands as far as the salary structure here. The government is kind of like the epitome of a good stable job, right? You get benefits, all these great things. Average government salary for an entry-level position is going to be between $26,000 and $40,000. That's the goal. That's kind of like the land of milk and honey in the Virgin Islands. When you look at being able to sit in your house, well, you could sit at the beach with a computer, writing code. You could be anywhere. you don't have to be stuffed in an office in a cubicle. You could be anywhere writing this code because you're going to usually be working collaboratively with people across the world, different time zones. Like, you just got to get the work done. And to think that you can make 3-4 times the amount that you would have been making working for the government sounds like a win to me.
It's all about learning something new or building upon something that you already have. Computer programming is around the passion for problem solving, the passion for puzzles
and logic.
And logic. Are those things that you enjoy? Or do you enjoy solving problems? Do you enjoy the gratification that comes from working your brain to figure out how I can make this the most efficient and also solve a problem for somebody, right? The greatest applications out there solve a problem for somebody, not the fart application, not the application that when you hit it, it sounds like a gun, not Flappy Birds. No, I'm talking about something like
I have an idea. Stop the train. So this is something that I would like to see in the Virgin Islands. I would like to see a marketplace app where we champion. Don't worry, dog. Don't worry. I want to see where we're championing the spirit of entrepreneurship in the Virgin Islands. And it's going to require a collaboration between the public and private sector, because agriculture would have to be involved, DPNR would have to be involved, because all the fishers and the farmers, this would be a plug-in for them to get their products out to the public. And I know we're used to our traditional Saturday morning market, but like, you could be selling your produce all days of the week, and you don't even have to leave your house. But that would involve creating an application that serves as a marketplace for the selling of goods and services here in the Virgin Islands.
Perfect. Yeah.
I know there's a property and procurement is rolling out a similar, I don't know if you would consider it like a mobile application, because I'm curious to see how the rollout goes. I think as of right now, it's like back end. I know there's going to be a front end version, but it's going to be where vendors for the government can access contracts for, you know how the government puts out bids for all these different contracts to, like, for construction and all of these different things. It's going to be that, but in a web form.
That sounds interesting.
So it's kind of like the marketplace application, but in government procurement framework.
Gotcha. That's interesting. Okay.
It'll be cool to see how that, how local businesses kind of fold into that. Mm-hmm. So I'm excited to see how that shakes down.
So, yeah. Me too. When they said that was coming
out? They announced it on their Facebook page maybe a week or two ago. So the businesses, I think, are going to be able to start signing up in September, with the goal being to roll out everything full-fledged, I think, January, February-ish.
Okay. Okay, cool. So, computer programming, and we bring up these salary numbers because the majority of the American populace isn't seeing this, right? They aren't seeing more than $50,000 a year. Right? Which means the majority of the American workforce is working paycheck to paycheck. Right? And so if we have such a emerging and robust industry that is just seeping out over the seams with job opportunity, but we also have statistics that say in the next 5 years we have over 1 million jobs that are just not going to be filled, that tells me that there's just a well of opportunity here. There's a well of opportunity here. And that well is, you can dive into it. You can dive right into it. But in order to be safe, right, and be successful in your dive, the equipment that you have to put on is understanding a programming language, right? Because
we're talking about digging into concepts like functions, variable,
exactly, that's just
syntax.
Yep. this is what I stress. So, me and my wife run a nonprofit here that's called the GeniusLogic Foundation, and we teach the youth and adults how to program in the Swift computer programming language. And so, through that, we stress that especially in the beginning phases, we stress that these are the building blocks. These are the building blocks of computer programming functions. Conditional code, working with if statements, working with loops, right? Working with dictionaries and arrays, and working with these foundations. That once you understand the foundations, you can then pivot to any other language language you want to go into. If you want to go into virtual reality, you want to go into game development, you want to go into database manipulation, you want to go into data analysis. Like there's so many different aspects avenues of the industry that you can get your hands into, but you got to understand the core. You got to understand the foundations of how the language works, right? Computer programming at the high level was basically built all using the same toolbox. It's just the tools in the toolbox are just shaped a little differently depending upon what programming language you want to use, right? So starting out in Swift is fine, but once you start in Swift and you learn Swift and you say, oh, I want to go over to Python, it's not going to take you as long to pick up Python because you already know Swift.
You have some foundational knowledge.
And then you're like, oh, I got Python. Let me get into Rubies and Rails. Let me do that. Oh, I got that. Let me get into C# because now I want to do some game development. You can pick up these things, right? And so my take right now, I'm doing a lot of this independent, right? My focus has been independence in computer programming. I haven't gone back to another big conglomerate company to take advantage of any of these high salaries, because I'm doing it independently. I want to bring the revenue directly into myself. But for those that don't have the aspirations of building your own, you want to work for a company and build on a larger project, working it as a team, as a junior or senior dev.
I think that experience is valuable, even if you do that before you work independently, because it gives you a framework for workflow to help you do that.
Now, I taught myself, but I also had the resources of Apple, the number one tech company on the planet, right? So me teaching myself and then going to like take tests and get certifications and things like that, it was much easier for me because I had those resources. Now, if you want to pick up a book or pick up, and not pick up a book now, we talk about the resources for computer programming. There's Swift Playgrounds. Swift Playgrounds is a great beginner foundational course, foundational tool that you can pick up and start playing around with the Swift operating system and the Swift.
On your iPad.
Yep,
on your
iPhone. You can do the documentation on your iPhone. iPad, you would need the actual iPad or a Mac to actually get Swift Playgrounds. There's the Learn to Code series, which is in iBooks. The Learn to Code series takes you from foundational code all the way up to building your first application and all the way up to being ready to start applying for some of these junior level computer programming language positions at some of these top companies, right? So you can start there, or you can go and learn from places like Coursera. There's one, Udemy.
Oh,
Coursera, excuse me. There's Udemy. We're going to put these down in the description notes. There's
Mimo.
Udemy. Udemy is a platform that has a plethora of different disciplines, but computer programming is one of them. It has all the computer programming languages on there. It's a self-paced course. And then there's also Mimo. There's a lot of applications that have self-paced courses in them as well that you can download from the App Store. Mimo was one that I would suggest. It's one that I suggest to my students as well. But you can look.
Codecademy. I almost forgot about Codecademy. That's a
good
one too if you want to do like web-based.
Yep. And there's a lot of organizations that help support you. There's Girls Who Code is one of them. There's Black Girls Code is another one. There's Code USA, which is another one. There's also I believe the Air Force has one. They have Cyber Patriot. That's more on cybersecurity, but there's also computer programming in that as well. So there's a lot of national organizations and initiatives that are occurring that you can latch onto. That if you don't know how to get in, if you're a little timid or you just have more questions. There are a lot of nonprofits that are out there that are supporting budding technologists and budding computer programmers to give you the resources and the support that you need to start you on that pathway, right? Because the jobs are there.
Yep.
It's just about filling them with people who are qualified. They're not going to give you these salaries unless you have the skills to do so. You don't have to go to college and get a computer science degree in order to become a computer science, a computer programmer for Apple or Google or Microsoft or Facebook. You don't have to go that route. Now, if you go the independent route, it may be a little more difficult, right? You have to have the discipline and the focus, just like you would if you were going the traditional route in school. Just because you're teaching yourself, that you don't lose that. It even becomes more so because you have to discipline yourself. Like I said, I spent every day after work locking myself in Starbucks in the corner with my headphones on, going through a book, calling people, asking, hey, how does this work? How is this work? Going on videos. How does boom, boom, boom? It took me a year and a half. Right? There's tons of resources out there. If you want to be a computer programmer, if you have aspirations of making that next app that's going to make $1 billion, if you have aspirations of working for Apple and working on that team to say, hey, I worked on all this software that everybody in the world uses. Like if those are things that you want, the opportunity is there. You just got to start, right? And so we're going to put all those resources down there in the description notes. You can have those links. We definitely want to say that you can reach out to us via email at joshuathegenius, right? joshuathegenius@gmail.com. That's genius with a J. Reach out to us if you have any questions, right? Like I said, I teach a lot of students here on computer science and computer programming. I've been doing it for about 3 years now, but I've been a computer programmer for about the past coming up 10 years now. Well, yeah, close to 10 years now, and being in the computer science industry over 15. So I definitely am a wealth of knowledge, and yeah, that's all I got.
So, just for people, this episode was kind of like a high level view of the computer science industry opportunities that are available for people to take advantage of. Following episodes are going to be kind of zoning in on specific concepts, so understanding functions, variables, constants, arrays, just all the things computer programming related. So look forward for that and keep an eye out for those future episodes.
Perfect. So thank you guys for joining us. I know this conversation was a little dense. It had a lot of acronyms and a lot of history, but I think that it's very, very important information. I think that it is very good for those that are stepping into the industry or that have questions about the industry to be able to hear someone who came through and got to the other side and to see what that journey looks like, right? Because we know what the standard journey looks like through going to computer science degree, submitting for a job, or going to an internship, submitting for a job, getting that job, working at that job for the next 30, 45 years, right? That's the traditional way to go. There's tons of different paths of coming into the technology industry. My way was just one of them. And so I just want to express to you guys that you have the support out there to be able to make your own way. If you have any questions, please feel free to reach out to us. For those that are here in the Virgin Islands, we do have a local repair shop here down off of Main Street. It's right across from Stonehouse Cafe, right above Valentine's Jewelry Box, and right next door to Chico Jewelry Repair, where we repair all Apple products. We do software and hardware support for anything that has an Apple logo on it. You can give us a call here at the store at 340-227-3821. And I also must speak about our crypto initiatives. I didn't last time on the podcast, but I will this time. So one of them first is we are taking and accepting all forms of Bitcoin, all forms of Ethereum, all forms of Ripple, all forms of Doge, and all forms of Litecoin, right? Top 5, right? We're accepting those cryptocurrencies for products and services here in the store. And you can pay us through joshuathegenius.crypto. JoshuaTheGenius.crypto is a cryptocurrency domain name. They basically took our public address and converted it into a readable public domain. If you want your own cryptocurrency public domain, you can get that at Kraken. Not Kraken. Excuse me. That's
It's a wallet, a digital wallet.
Yeah, and that's an exchange. The Unstoppable Domains, Unstoppable Domains, and when Unstoppable Domains decides to pay us for ads, I'll get their ad better. So Unstoppable Domains, you can go and get your own .crypto. There are some others out there now. There's like .BTC, .eth. I think Budweiser just bought beer.eth, I think, and also just released the NFT. But yeah, beer. The Budweiser company just bought beer.eth. And so to see larger corporations getting into the market just increases the credibility and awareness of what's going on. So I always like to talk about the crypto industry and what's going on because I'm a huge supporter in it. And I think this is one of the more functional parts of it. So Unstoppable Domains, that's where you can get your own cryptocurrency domain, and it makes it a lot easier for when you are purchasing or selling any types of goods or services. Instead of sending out that long string of characters, you can just give them your domain name like you would a website. Also, if you are interested in buying any cryptocurrencies and holding them for yourself for an investment, you can do so through the Coinbase application. Coinbase is a free application that gives you access to an entire market of cryptocurrency that you can buy, and you can attach a credit card and or your bank account right to it. You can start your first purchases of cryptocurrency through there. If you use our link down at the bottom, you get $10 free of Bitcoin. Right? So if you're into cryptocurrency and you want to start buying, you can do so at Coinbase.com. I think that's it.
Yeah,
that's it. And if you guys need anything from us, you want to know more about the podcast, you want to know more about the store, you want to look at some of our merch, we have some t-shirts on sale, we're going to be having some other things up there soon. You can do so at JoshuaTheGenius.com. That's Genius with the J. JoshuaTheGenius.com. And you can find us there. Okay, so thank you guys for tuning in. And